Hey everybody! Today's practice problem comes from Microeconomics by Dirk Mateer and Lee Kopic. Today we're going to be doing Chapter 9, Problem number 5. The problem begins by giving us a graph that looks something like this and then asking us some questions about it. So let's just think about what this means here. Again, we have on our horizontal axis, we have quantity produced. So I put little q here for individual firm quantity, as opposed to capital Q for market quantity. And then we have some cost curves. We have marginal cost, we have average total cost, and we have average variable cost. And these look typically like we've seen so far. We have marginal cost that decreases for a while and then starts increasing after you hit a certain production quantity. And that just happens because of diminishing marginal products. That's pretty typical. And then we see a U-shaped average total cost and a U-shaped average variable cost, which we also said was typical. And of course, these U-shaped cost curves intersect marginal costs at their minimums. That's always going to be true as well. It's not obvious from context here, but you'll notice if you have a copy of the book that Chapter 9 is called Firms in Competitive Markets. So the implicit assumption here is that we are in a competitive market. So basically these firms with these cost structures, there's a bunch of them, and they're taking prices given. They don't have to lower their price to sell more. So we have a bunch of hypothetical prices here, which would just be those market prices that they're taking as given. And you're just going to be asked, what prices are these profits going to be made, and so on and so forth. So these are our hypothetical sets of prices. The other thing to keep in mind, because the problem asks about economic profit, is that these cost curves actually represent total economic costs. Yeah, I called it average cost. But when I mean total economic cost, I mean we're counting both explicit costs where you're writing a check or paying cash or monetary layouts, but also implicit costs as well. So when we're comparing total revenue and total cost based on what we've calculated here, we're actually calculating economic profit rather than accounting profit. The first part of the problem asks, at what prices is the firm making an economic profit, breaking even, and experiencing an economic loss? And you can see that because this question is asking about economic profit and economic loss, it's actually really important to keep in mind that all of these costs are counting both explicit and implicit costs. So if we're going to analyze at what prices there are positive economic profits to be had, negative economic profits to be had, etc., there are two things that we need to keep in mind. The first one is what profit actually is. So of course we say profit, which I've noted as pi here, that's fairly common, is just equal to total revenue minus total cost. But we can do some quick arithmetic. We can say there's actually another way that we can represent profit that's really helpful to thinking about this particular question and most profit type questions that we see in these sorts of exercises. We can say profit is also represented as the quantity produced times price minus average total cost. And this is important because quantity produced is never going to be negative. So if we're assuming that we're producing some positive quantity of output, our profit is going to be greater than 0 when the price is greater than the average total cost of production, because then when we subtract, we're going to get a positive number. Profit's going to be negative when the price in the market is less than the average total cost of production, because now when I subtract, I'm going to get a negative number. And profit's going to be exactly 0 when the price charged is exactly equal to average total cost at the quantity produced. So we can see how this simplifies our exercise a little bit, because we can just say, well, at each price we can figure out what quantity is being produced, and then we can find out the average total cost of that quantity, compare it to price, and see whether our profit is positive, negative, or 0. So, well, okay. So we need to figure out, well, how do we know what quantity is going to be produced? And we know what quantity is going to be produced because it's the profit maximizing quantity for the firm, right? So we also know that profit is maximized where marginal revenue is equal to marginal cost. And if we're assuming that we're in a competitive market, as we said before, that we're just taking the market price as given and we can sell as much output as we want at that market price, then we're not going to have to lower our price in order to sell more output, and marginal revenue is just going to be equal to price. If we had to lower our price, if we weren't in a competitive market and we had to lower our price in order to sell more, marginal revenue would be something less than price. So this isn't always true, but this substitution can be made when we're looking at a competitive market. So just knowing this, we can actually infer, assuming that we're going to be producing something. We'll come back and think about whether it's even worthwhile to produce anything in the first place. But assuming that this firm is going to be producing output, we can figure out at each of these prices how much output they're going to want to produce. That we could just say, okay, we can find at each of these prices the point where price is equal to marginal cost, and that's going to be our profit maximizing quantity, assuming that we're producing. So at price P6 here, I can label this quantity here as Q6, that's going to be the profit maximizing quantity. At price P5, the firm's going to want to produce this quantity here, call it Q5. At price P4, the firm's going to want to produce this quantity Q4. At price P3, the firm's going to want to produce this quantity Q3. At price P2, if the firm's going to produce, the best it can do is quantity Q2. And then this P1 is a little bit weird, because we get down here and we say, oh, actually, there are 2 points where price is equal to marginal cost. Which one is actually profit maximizing? Well, if you think about this, at this first intersection quantity here, the firm has only produced units where marginal cost is greater than price. That doesn't seem very profit maximizing. Whereas here, yeah, it produced some unproductive units over here, but then it made up for it because it produced units here where price was greater than marginal cost, right? So we can say that actually our profit maximizing quantity, assuming that we're going to want to produce anything in the first place, is going to be this Q1 here. It's not going to be this one on the left. But again, this is all assuming that we're producing. And we're going to have to come back and think about whether or not we actually want to be producing in the first place. So if we want to think about those prices where the firm is making a positive economic profit, we want to find those prices where price minus average total cost at the profit maximizing quantity is greater than 0. It's probably not going to be shocking to you that higher profits exist at higher market prices. You know, all else being equal, higher market prices are going to be more profitable and lower market prices are going to be less profitable. And we're going to see that as we're going through our different options. So if we're assuming here that these are the only 6 possible prices to pick from, I can start at this top one here and say, well, at this price P6, the firm's going to want to produce this quantity. So they're getting a price P6, and they're operating at an average total cost of something lower than P6. So the difference between price and average total cost, this quantity, is going to be greater than 0, and hence economic profit at this quantity is going to be greater than 0. Let's put a little pi greater than 0 over here. The same is going to be true at price P5, that we can say at price P5, they're going to be producing this quantity here. So they're going to have an average total cost down here and a price up here. Again, price minus average total cost is going to be positive, and economic profit is going to be positive. At price P4, the firm is going to be producing quantity Q4. And this is going to be where price is exactly equal to average total cost, right? So here is where our economic profit is going to be 0. We can keep doing this, and it's not going to be surprising that at the rest of these prices, our economic profit is going to be less than 0, because I said higher prices correspond to higher profit, and lower prices correspond to lower profit. And we can see that. We can say at P3, we're producing here, getting a price P3, producing at an average total cost up here. So price minus average total cost is going to be negative. Economic profit is going to be negative. Price P2, we're producing quantity Q2, getting a price here, producing at an average cost all the way up here. Again, price minus average total cost is going to be negative, so economic profit is going to be negative. And put those guys in here. And lastly here, P1, you have a price down here. You're producing at an average cost all the way up here. Price minus average total cost is going to be negative. Economic profit is going to be negative. So you can see a general rule here. You know, we went through and derived it. But the general rule is that when the market price is strictly above the bottom of this U-shaped average total cost curve, economic profit is going to be positive. When market price is exactly at the bottom of this average total cost curve, economic profit is going to be 0. And if price is below the bottom of this average total cost U-shaped curve, economic profit is going to be negative. So you don't have to go through this exercise every time. You can just look at those different regions, but it's helpful to understand why this in fact works. The next part of the question asks, at what prices would the firm shut down? So to think about that, it's worth reminding you of a few things. One, we're talking about costs in the short run here, that, you know, unless stated otherwise, these costs refer to short run rather than long run costs. And we think about in the short run, what does that mean? In the short run, we've already decided that we want to be in this industry. We've already paid our fixed costs. And our fixed costs are there regardless of whether or not we produce anything. So when we're saying, do we want to produce or shut down, we're saying, well, which one of those is more profitable, obviously. But which one of those is more profitable under the assumption or the condition that we've already paid those fixed costs and they're not recoverable? So what we end up seeing is that it's worthwhile to produce as long as we're covering our variable costs, right? That we have something called the shutdown condition. And the shutdown condition says that we want to shut down when the total revenue that we're bringing in from producing actually doesn't cover our total variable costs. That there's no way to even recoup our variable costs, and therefore by producing, we're just digging ourselves more and more into a hole, right? But this is going to be true. We want to shut down. We can do some math on this, just like we did some math on this. I'm not going to go through the derivation, but we want to shut down when the market price, at the best we can do, is less than our average variable cost. Because then we say, well, the extra dollars coming in from staying open is this price P per unit, and that's not even covering, on average, the variable costs associated with being open. So this is going to be when we're digging ourselves more into a hole from producing, and it's actually going to be better for us to just sit there. So we can come back here, and we can say, well, when do we want to produce and when do we want to shut down? And again, it's pretty clear that if we're making a positive economic profit or even a 0 economic profit, we're going to want to be producing. And we could also see clearly that at price P6 we're going to be producing here, we're clearly getting a price higher than average variable cost. Similarly, price P5, we're getting a price here average variable cost here. We're clearing average variable cost. Price P4, we're getting a price here. Variable cost is here. Still covering our variable cost. We get down to P3, and now we're in negative economic profit territory. And this is where we're going to be worried about, do I actually want to shut down or produce? So at price P3, the best we could do is to produce this quantity Q3. So we're still getting a price that's above our average variable cost. We might be making a negative economic profit. We can see that we are here. But basically this is saying, at least by producing, we're going to start paying back our fixed cost. Like say you have a fixed cost of $10,000. Would you rather lose $10,000 or $2,000? In both cases, you're losing money, but it's still better to lose less money. So at this situation here, at price P3, it might be the case that producing still leaves you with negative $2,000, but you would have gotten negative $10,000 if you hadn't produced anything. Because at least here, the price starts covering your average variable cost and then some, so you're eating into your fixed cost, but you're not paying entirely. Price P2 here, on the other hand, the best we could do is to produce this quantity Q2. And now we notice that we're at a price that's below average variable cost at that quantity. So here, we'd actually want to shut down. Similarly, at price P1, we'd also want to shut down because the best we could do if we were going to produce is to produce this quantity Q1, and we're not covering our average variable cost at that quantity. So we can say here we also want to shut down at P1. And you'll notice that we can come up with a bit of a simpler rule for when we want to shut down. Because of the way that these cost curves are structured, we can actually say that we want to shut down not only when the price that we get is less than the average variable cost, at the profit maximizing quantity. That's always implicit in whatever we're saying here, even if it's not explicitly stated. We can say that we want to shut down when our price is less than the minimum average variable cost that we can achieve. So when price dips below the bottom of this average variable cost U is where we want to shut down. And we see here that P3 was still above the bottom of the average variable cost U, so we wanted to produce, but P2 and P1 were below it, so that's where we wanted to shut down. The last part of the question is two parts, actually. The first says, at what prices does the firm's short-run supply curve exist? Now, this is sort of a weird way of phrasing the question because I would argue that the supply curve exists at all prices, but I interpret this as at what prices does the supply curve actually show some non-zero level of production, right? And under that interpretation, then our short-run supply curve is going to exist wherever we're getting a price that's high enough to not shut down, right? Though we said here, our short-run supply curve may sometimes result in negative economic profit, but it's going to exist or produce a positive quantity whenever producing is more profitable than not producing in the short run. So we said here that that's going to be at prices P3, P4, P5, and P6. So what our supply curve would essentially do would be at prices P1 and P2, we would just be at a quantity of 0. And then when we decided to not shut down anymore, it would sort of jump over to that profit maximizing level of production. So we could either say if we're restricted to these prices that our short run supply curve would exist for P3, P4, P5, and P6, or we could say that in a more continuous sense, our short run supply curve would start existing at this bottom of the average variable cost curve here. And what we know from our earlier studies is that the individual firm supply curve in the short run just looks like the marginal cost curve, but it's a truncated version of the marginal cost curve because it's only going to produce positive quantities when it's clearing that shutdown condition. So what we would see for a supply curve is it'd be at zero for a while, and then once we get to this bottom of the average variable cost curve, our individual firm supply curve is going to look like this marginal cost curve here. The second part of the last part of the question asks, at what prices does the firm's long-run supply curve exist? And this is an important thing to think about because in the long run, we say, well, what does that mean for firms? In the long run, firms have the opportunity not only to shut down, but to fully exit an industry or to fully enter an industry if they're not already there. So in the long run, these fixed costs are no longer sunk, and we don't truly have any fixed costs in the long run, is one way of thinking about it. But more specifically, what we see is in the long run, a firm will exit an industry if it's making negative economic profit, and it will enter an industry if there are positive economic profits to be made. So in a long-run equilibrium, economic profits are zero in a competitive market, because we're going to have firms coming in and competing the profits away whenever there are positive profits to be had, and we're going to have firms leaving and pushing prices up whenever there are negative profits to be had. So we can say that once we know that our long-run equilibrium is going to be the point where firms are making zero economic profit, we can then say, well, zero economic profit happened when the price was just hitting the very bottom of this average total cost curve. So we could say, based on this diagram alone, I can infer that the long-run equilibrium price in this market, if all of the firms face these same cost curves, has to be P4, because this is the point where they're making zero economic profit. And it's sort of weird to think about what a long-run supply curve for a firm would look like as opposed to the long-run supply curve for the market. Because what's really going to happen is in the long run, only this price P4 is relevant, right? And at this price P4, the firm's just going to be producing this quantity Q4. So really, the long-run supply curve for an individual firm is really just this point here, because that's always where they're going to be at in a long-run equilibrium in a competitive market.